Hi everyone, Tina here, and today I'd like to talk about differentiating parametric equations. You'll usually come across this topic during year 2 of your A-level course. I've made other videos on differentiation, so I'd recommend you watch those ones as well. Parametric differentiation is effectively just an application of the chain rule, so we're going to jump straight into some examples and I'll show you how it works. Example 1. A curve has the parametric equations x equals sine squared t and y equals sine 2t, where t is between 0 and pi. Part A, find an expression for dy dx in terms of t. So the main chain rule that we want to do here is to get dy dx, and we can do that by splitting the dy and the dx like this and filling in the gaps with dt. That is, as I said, just an application of the chain rule. The dt's would cancel and that's dy dx. In order to actually get dy dt and dt dx, we have to differentiate each equation at the top separately. If we start with the x equation, this is the same as x equals sine t all squared. So again, you might want to do a chain rule for this. You could say x equals u squared, where u equals sine t. You could then do dx du equals 2u, and du dt equals cos t. You could then get dx dt by timesing both of those together. So 2u cos t, which is the same as 2 sine t cos t. For the y equation, we've got y equals sine 2t. So again, we might want to do a chain rule. Y equals sine u equals 2t. dy du is cos u, du dt is 2. Means dy dt is those multiplied together, so 2 cos u, which is the same as 2 cos 2t. Now there are 3 separate chain rules on the page here, so I'd recommend you keep this working out completely separate on your page so that you can see what your main chain rule is. Let's highlight the key findings. So we wanted to find dy dt here, and we did here. Dy dt is 2 cos 2t. We also wanted to find dt dx, and we found dx dt to be 2 sine t cos t. So if we put those in, dy dt was 2 cos 2t times 1 over 2 sine t cos t. That is just as it comes, dy dt. And this one's been flipped upside down because it's dt dx. We can then multiply those two things together. We get 2 cos 2t over 2 sine t cos t, and we can cancel the 2's. Means we get cos 2t over sine t cos t. And that will do for our final answer, an expression for dy dx in terms of t. Part B, find an equation of the normal to the curve when t equals pi over 6. So anytime we're looking for equation of a tangent or a normal, we know we're going to need our derivative, which we found in part A to be this. We can then use that. So let's sub in when t equals pi over 6. Find out what dy dx is. You get 2 root 3 over 3. And that's the gradient of your tangent. Therefore, the gradient of the normal is going to be that negative reciprocal, so minus 3 over 2 root 3. In order to find the full equation of the normal, we also need to know an x-coordinate and a y-coordinate. So let's find those out. For x, let's sub in t equals pi over 6. So sine pi over 6 all squared is a quarter. And for y, we got sine and then 2 pi over 6 equals root 3 over 2. Putting it all together, I usually do y equals mx plus c, but you can do whatever straight line method you like. Let's sub in the relevant values. So y was root 3 over 2. M, gradient, was minus 3 over 2 root 3. This was a quarter. C is what we want to find. Rearrange and solve for C, and you get 5 root 3 over 8. Means final answer will be y equals minus 3 over 2 root 3x plus 5 root 3 over 8. And that's it. Example 2. A curve has the parametric equations x equals ln t plus 1 and y equals t squared minus 5. T is greater than negative 1. Part A, find the points where the curve crosses the coordinate axes. Now this is more of a parametric equations question rather than parametric differentiation, but I'll go through it anyway. For the curve crossing the coordinate axes, we're going to be thinking about when x equals 0 and y equals 0. So let's start with when x equals 0, what's happening? So that would be ln t plus 1 equals 0. If you solve this for t, you're going to end up with this. You can then sub that into the y parametric equation. So you get y equals 0 squared minus 5, which is just minus 5, means the coordinates are 0, minus 5. Something really similar now for y. So when y equals 0, t squared minus 5 equals 0. Solve for t. Get two possible answers, root 5 or minus root 5, but minus root 5 is around minus 2.24, means invalid in this question because we're told that t has to be greater than -1. So the only t value we're interested in is root 5, means x would be ln brackets root 5 plus 1. So the coordinates would be ln root 5 plus 1, comma 0. Those two final answers for part A. Part B, find an equation for the tangent to the curve when t equals 3. So equation of a tangent, we're going to need the derivative, dy dx. Chain rule says that this would be equal to this, because the dt's would cancel out. So that means we need to find dy dt and dt dx. To do that, again, we just take the original parametric equations and differentiate them separately. So for x, I would probably do a chain rule again. So x equals ln u, where u equals t plus 1. dx du is just 1 over u. The u dt is just 1. Means dx dt, multiplying those together, nice and easy, is just 1 over u. So just 1 over t plus 1. dy dt, in this case, no special methods needed, just an ordinary differentiation 2t. Keeping that working out separate, can now insert those where they need to go. So dy dt was 2t, and dt dx will be dx dt flipped upside down. So t plus 1 over 1 simplifies to 2t brackets t plus 1. So let's just recap where we got those from. dy dt, 2t from here. dt dx here was dx dt flipped upside down. Now we look at the specific point. So when t equals 3, let's find the various pieces of information we need. So when t equals 3, dy dx, or gradient, is going to be this. X is going to be this. Y is going to be this. Put it all together. 4 equals 24 ln 4 plus c, means c equals 4 minus 24 ln 4, means full equation is y equals 24x plus 4 minus 24 ln 4. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.